Hey everyone, and welcome. We're all hearing the hype around generative AI, right? But how do you actually get from all that buzz to a real working application that runs on AWS? Well, today we're going to cut through all that noise and build a concrete architectural plan. Let's dive right in. So picture this. Your boss comes to you and says, "We need a Gen AI app." Suddenly you're looking at this mountain of possibilities and let's be honest, it can be pretty overwhelming, right? You've got all this incredible tech, but turning that into a solution that's actually ready for production, that's a huge challenge. And it's a question basically every engineer and architect is wrestling with right now. And look, the answer isn't about chasing the latest, shiniest model. The real key here is having a blueprint, a repeatable structure of process that guides you all the way from some vague business idea to a scalable, really well-architected solution. And that's exactly what we're going to build today. Okay, first things first. Before you write a single line of code, before you even think about which model to pick, you have to start with the why. So, step one is all about taking a real business need and turning it into an AI problem we can actually solve. This slide really breaks down how practical that translation can be. I mean, look at it. Is your support team just swamped with tickets? Bam! The use case is an AI-powered chatbot. Are you buried under endless reports? Document summarization. Hitting a creative wall? Content generation. This mapping is absolutely the most critical first step to make sure you're building something that people will actually use and that delivers real value. All right, so you've got your use case nailed down. Now it's time to put on that architect hat. And step two, we get to design the core system and start making those key technical choices that are going to define the entire application. Okay, so your whole design is going to boil down to three massive decisions. First, the foundation model. Are you going to use something super powerful like Anthropic's Claude for really complex thinking, or maybe something faster like Cohere's Command for quick back and forth? Second, integration. How is this model going to access your company's private data? Maybe through a Lambda function that's connected to a database. And third, deployment. How are your users going to access it? Probably through a secure API gateway endpoint. Every single one of these choices has major downstream effects. But here's the reality check, right? You're not designing this in a bubble. Every single choice you make is going to be pulled in different directions by three critical constraints. How much is this thing going to cost? How fast does it need to be? And does it meet all our security and compliance rules? These aren't just afterthoughts. They are the absolute guardrails for your entire project. Now, this is absolutely crucial. There is no single best model out there. It just doesn't exist. It's all about the best model for your use case. Just look at this comparison. On Bedrock, you could use a model from the Claude family. It's incredibly powerful, amazingly accurate, perfect for deep analysis. But it's also slower, and it costs more for every token. On the other hand, a model from the Cohere Command family might be way cheaper and faster, making it perfect for a real-time chatbot. You're always making a trade-off. So you've got your design, you've picked a model, and it's so tempting to just dive in and start building the final product. But whoa, hold on. That is a huge risk. And that brings us to this incredibly important money-saving step, the proof of concept, or POC. It is all about validating your assumptions before you go all in. So what is a POC? It's really simple. It's just a small, super focused experiment. The goal isn't to build some polished, finished product. It's to answer one single question: is this design actually going to work in the real world? You build just enough to test your core ideas and see if they really hold up. So when you're running this POC on a service like Amazon Bedrock, you're really trying to validate four key things. First, feasibility. Does the model even do what you hope it can do? Second, latency. Is the response time actually acceptable for a real user? Third, cost. Do the API costs you're seeing line up with your budget, or are they going to spiral out of control? And finally, quality. Is the output actually any good? Is it useful? Just think about the power of that for a second. A focused 2-week experiment can give you the hard data you need to avoid pouring millions of dollars and months of your team's time into a project that was basically doomed from the start. The return on investment for a good poke is, well, it's just off the charts. Okay, so your POC was a massive success. Awesome! Now what? Well, you can't have your teams building every new Gen AI project from scratch. That's just not going to scale. So the final step is to take what you learned and standardize it, creating reusable patterns so your whole organization can build things quickly and safely. And this quote from the source material just nails it.
The ultimate goal isn't just one successful project. It's about developing the capability as a company to rapidly and reliably produce high-quality, sound architectural designs for any Gen AI workload that comes down the pipe. It's about building the factory, not just a single car.
And the good news is, you don't have to invent this framework from scratch. AWS has literally given us the playbook for this. It's called the Well-Architected Generative AI Lens. It's a whole set of best practices and design principles that guide you in creating these robust, scalable, and reusable solutions.
All right, let's take a step back. We've gone all the way from a fuzzy business problem to a scalable, repeatable process for the whole organization. Let's pull it all together one last time and look at the complete blueprint we've just built.
And here it is, your 4-step blueprint for getting this done right. Number 1, translate the business problem into a real use case. Number 2, design the architecture around your constraints. Number 3, validate everything with a small-scale POC. And finally, number 4, standardize that success into reusable patterns for everyone else. This is your path from hype to production.
Look, if you follow this process, you have a clear, logical, and honestly a defensible path to building real-world generative AI applications that actually work. The framework is here. The blueprint is in your hands. So the only question left is, what incredible solution are you going to build first?